Hello everyone, I'm Anusha. In this video, I'm going to explain the concept called thread-based multitasking versus process-based multitasking. So, what is this thread-based multitasking in this sense? First of all, so this thread-based multitasking is going to enable a program to carry out two or more tasks in form of threads simultaneously. Okay, so it is going to enable a program to carry out two or more tasks in the form of threads simultaneously is called thread-based multitasking. Whereas coming to this process-based multitasking, so it is going to execute two or more programs concurrently. Okay, so whereas thread-based multitasking is going to enable a program to carry out two or more tasks in the form of threads, whereas this process-based multitasking is going to enable a system to execute two or more programs concurrently. So this is how the definition itself is varying in between this thread-based multitasking and then process-based multitasking. So coming to the first difference, so here I'm going to categorize this process-based multitasking and the thread-based multitasking in the form of these variations. So first one is the smallest unit. So under this process-based multitasking, so a program is said to be the smallest unit that can be executed independently. Here, a program is the smallest unit that can be executed independently in process-based multitasking. Whereas in thread-based multitasking, under this smallest unit, here a thread is said to be a smallest unit that is going to get executed independently. Here, the smallest unit is the program, and here the smallest unit is a thread. Okay, so next difference is overhead. So coming to this overhead, in this process-based multitasking, so it is going to put more overhead than the thread-based multitasking. Okay, that means there will be more overhead in this process-based multitasking when compared with thread-based multitasking. So that's why we have represented, so the overhead is high in process-based and low in thread-based. Okay, next one is address space. See, a process is going to perform heavy tasks and takes up a separate address space in process-based multitasking. Okay, so it is going to perform heavy tasks and going to take a separate address space. Whereas here, a thread is going to perform light tasks and going to share the same address space with the other threads, so which is belonging to the same program. Here it is belonging to the separate address spaces, whereas here it is belonging with the threads of same program. Okay. Next, context switching. So this context switching in the case of this process-based multitasking is, so the context is switching from one process to another process is going to cost high in this process-based multitasking. Okay, so to switch from one process to another process in this process-based multitasking, so the cost is going to get high in this process. Whereas when compared to this thread, to move or else to switch from one thread to another thread, so it won't get, that means it won't reach that much cost level. Okay. Next, coming with the communication, that means inter-process communication. See, this inter-process communication is limited and is expensive in process-based multitasking, whereas in thread-based communication, it is an inexpensive in this thread-based multitasking. Here it is a limited and expensive. This is inexpensive. And so we are also calling this process-based multitasking as heavyweight process, and thread-based multitasking is lightweight process. See, here we are defining a thread itself as a lightweight sub-process. No, so that's why we are saying it is a lightweight process and this is a heavyweight process. Okay, and this process-based multitasking is best suitable for OS levels, operating system level, and this thread-based multitasking at the programmatic level. Okay, that means it is best suitable for programming level and this is best suitable for OS level. Okay, so if you consider some of the examples that comes under this process-based multitasking is executing MP3 player, text editor, browsing concurrently. Okay, so we can switch now. So we can so by making by browsing the net, so we can move to the text editor and we can move to the MP3 player. Likewise, so we are having a more option to switch from one process to the another process. Here, printing documents as well as keep editing on a text editor all comes under the thread-based multitasking. Okay, so these are all the some of the differences that is going to held in this process-based multitasking and thread-based multitasking. Okay, so first we want to know what is this process and what is the thread. Right. So we are very well known about this. What is a process and what is a thread? We are saying that a process is a program in execution, right? So here each process has its own address space, program counter, data section, stack, and register set. See, a process is a program in execution, and here each process has its own address space, program counter, a data section, stack, and register set. Whereas coming to the thread is an independent dispatchable code. So which will be having unique path of execution. Here, so each thread has its own program counter, its own stack and register set. So despite of all share same address space. Okay, so this is the main difference between the process-based multitasking and thread-based multitasking. Okay, so just we are going to differentiate in these bases how the communication will be in the process-based and how the communication will be in the thread-based. Okay, so what is the smallest unit in this one and what is the smallest unit in thread-based? Likewise, we are going to differentiate each and every concept under this thread-based multitasking and then process-based multitasking. Okay, so if we are coming across with the definition of this process-based multitasking in the sense, it is going to enable the system to execute two or more programs concurrently. Whereas here it is going to enable a program to carry out two or more tasks in the form of threads. Okay, so starting from the definitions till the end of this example, we have come across with the all differences in this thread-based multitasking and then process-based multitasking. Okay, so next concept is understanding Java thread model. Here, as we know that the thread is in Java program is going to run asynchronously as an independent path of execution, right? So it is basically a subset of code, so which is designed to execute simultaneously. So in synchronization with the other subsets of the same program, right? That is what we have discussed in the earlier slide, right? So the main motivation behind this threading is to leverage this concurrency. Okay, so but the problem is that here the programs that work with this parallel logic are not only difficult to conceptualize, but also so it is very much difficult to implement consistently. Okay, so even if so we are going to devise this logic to work in a parallel mode, here we are not that means we cannot be sure about its consistency, because so concurrent execution of the code is going to raise numerous issues such as so synchronization, deadlocks, atomicity, and resource sharing, etc. Okay, so here we are going to discuss how we are going to define this thread in a various levels. Okay, so if we are treating this thread as a process, okay, so see these operating systems which is evolved to run more than one process at once, right? So that is a main difference we have discussed in the earlier slide. Okay, so that means process-based multitasking is applicable to the OS level, right? Here, so these process execute in an isolated way and it is in an independent manner. Okay, so in which so the resources are allocated such as memory. So I'm discussing about the process. Okay, here it is going to handle the files and also some with the security credentials. So on occasion, so this one process communicates with the another through a communication mechanism called sockets. Sockets, signals, shared memory, semaphores, and files. Okay, see, whereas a thread, it is also similar to this process. Okay, but so it works on a smaller scale. Okay, so that's why we are calling this thread as a lightweight process and process as a heavyweight process. Okay, so it is going to make multiple streams of programs. So this control flow is in between, within the process only. Okay, so it won't go out of the process. That means it is going to perform multiple streams within the process. Okay, so that's why we are saying thread as a process, but it is both are not the same. Okay, so thread will be acting like a process, but thread and process are different. Okay, it is a heavyweight process, whereas thread is a lightweight sub process. Okay, so next about thread safety. See, we can say that in this imperative programming languages, our Java is an imperative programming language, right? See, it is not easy to create a parallel logic. So without closely considering the issue of thread safety. Okay, so why? Because it is not an inheritance principle of this language design. Okay, so here, so the code must be designed in a thread safe manner first. Okay, so we need to follow. That means there is no strict rules to ensure the safety of the thread. Okay, but we need to consider, and so we need to follow some of the rules. Okay, first one is we need to minimize the sharing or objects among the multiple threads. Okay, however so how much option we are having to minimize the sharing, that much we have to utilize, and we need to concentrate on minimizing the sharing. Next, we need to apply locking and when working with shared resources. Okay, that means we are not intended to allow that shared resources to share with the another resource. Okay, so whenever it is in a sharing process, we need to lock it. Okay, next, local variables are thread safe because each segment has its own copy. Why? Because we will be maintaining the copy of that particular segment. So it will be maintaining its own copy. Next, volatile keywords can be used to ensure that threads do not cache variables. Okay, so here we are saying that volatile keywords can be used. We are having an option to use this volatile keywords. Okay, so for ensuring that threads can be using this cache. Okay, cache variables. Okay, see the main problem with this multi-threaded programming is that so it is going to give the power of concurrency and it is going to ruin at the same time. Okay, so that is the main problem with multi-threading programming. Why? Because it is going to give the power of concurrency and it is going to ruin in the same time. Okay, so next, coming to the concept called so thread in a Java memory. Okay, so here, so as we know that, so to understand this Java thread model, so it is necessary to understand at least a few aspects of Java virtual machine, okay, or memory layout. Okay, so why? Because memory is the playground of the threads. We can say that memory is the playground of threads. Why? Because here the JVM is a system that is going to run on the top of the actual operating system. Okay, so it will be having its own memory management scheme that is going to work in an synchronization with this underlying platform memory architecture. Okay, so that means the complete thing will be running towards this JVM. So which is going to run on the top of the actual operating system, and it will be maintaining its own memory management scheme. Here, so this Java memory manager is going to specify how that a particular thread is going to work with this synchronizing process. Okay, so while sharing this variables, while getting the access to make use of that shared variables, how it is getting the synchronization process in this by making use of this JVM. Okay, see here this is going to specify the two segments in this memory called one is with the stack area and another one is the heap area. Okay, one is with stack area and this is the heap area. So this is how the thread Java thread manager is going to specify the two parts of this memory. Okay, see here the each running with the thread creates its own stack in the stack area. See here, it will be creating its own stack in the stack area. So this stack is going to contain all the information specific or else local to the thread. Okay, so such as it's a declared primitive variables and method calls. Okay, so this area is not shareable between the threads, and the stack size is going to change dynamically according to the running condition of the thread. Okay, so here this area is not shareable between the threads. Okay, and the stack size is going to change dynamically according to the running condition of the thread. Whereas coming to this heap area, so this heap area is for storing objects. See, if you observe here, it has been represented with object 1, object 2, and object 3. So this is used for storing the objects that is created by the Java application. So these objects are shareable by all the threads. Okay, and also can access the objects methods if it has any references to it. Okay, so in that case, 2 or more thread calls a shared object method. Okay, or it's a member variables. So each gets a copy of it and stores it in their local stack area. Okay, so this is how this JVM, that means, is going to manage with the two segments in the memory called, one is with the stack area and another one is the heap area. So whatever the things we are going to represent in the stack, so here it is not shareable between the threads, whereas in the heap area, the objects or else the memory variables will be shared among the threads. Okay, so this is, so in this video we have come across with the concept difference between the thread-based multitasking and process-based multitasking. And next one with understanding the Java thread model as a thread as a process and about its thread safety and thread in a Java memory. Okay, thank you.